look at one more implementation of while loop. This time we'll try to find the reverse of a given integer number. Now there are different ways to do this particular task of finding the reverse of a number. One of that particular task is to find the reverse of the number using a while loop. We'll use some arithmetic expressions to find and store the reverse of a number. I have a code partially written for this, so we are supposed to do some additional instruction placement in this particular code. Let's try and place these instructions. Let's explain this program with an example itself, and we'll arrive at some expression which is supposed to be placed in the while loop. So let's take a number as say n, which is say 523. Let's ask the user to enter the number, read that number as 523. Initially, let's assume r as garbage. I don't want to accumulate the values of r. Now I have to accumulate or I have to store these values of r in a reverse order. Hence for that, I'll take a variable as a rev, which is set to 0 initially. Even you can use the variable s also. I will not say that s is not advisable. So generally the variables need to be associated with the name such that they will indicate what these quantities are. So I'll say n, r and rev are the variables which I'm going to use. I'd ask the user to enter the number which the user has entered as 523. Now the while loop still remains same. So 523 greater than 0, true. True in the sense this will repeat the operation of extracting the digits. Let's start the first operation. So I'll say 523 mod 10 is 3 and 523 by 10 is 52. Now what I need to do is I need to place the value of r in rev with some logical based expression. If rev has got a 0, then what I'll do is I'll just place this particular 3 onto rev right now. We'll come back how exactly we got this particular 3. Now let's start with the second execution. When I say second execution, it says 52 mod 10 because 52 is greater than 0. True in the sense I have to start the second expression. 52 mod 10 is 2 and 52 by 10 is what? 5. Now question comes, how do I set the value of r onto rev? The value of r has to be logically placed onto rev. How? If rev has got a number which is non-zero in the unit position, then this number should be shifted to the 10th position. And the value of r has to be accumulated into this particular rev at the unit position so that the number now it is constructed is 32. So what I did was the value of r got into the unit position and the value of rev which was already existing has went to the 10th position. So I have to shift the digits of rev by one position towards the right hand side. Let's try the third operation because the third operation is possible. 5 greater than 0, true. 5 mod 10 is what? 5. And 5 by 10 is 0. These are the results of the third expression. Now I am asking you to store 5 onto rev. How to make this particular 5 onto rev? I have to make this particular r to accumulate at the unit position of rev. But there is already a digit in the unit position. That should get shifted to the 10th position. There is already a digit in the 10th position. That should get shifted to the 100th position. So it means that 5 should accumulate to the unit position. 2 should accumulate into the 10th position. And 3 which is in 10 should accumulate into the 100th position. The result is 325. And 325 is nothing but the reverse of 523. It is very easy to say the results, but how do I get to this shifting of digits from unit to 10, 10 to 100, 100 to 1000 and so on. So let's try a logical expression. So if I have to take this 32, let's start from bottom. So 32 has to be shifted. When I ask you to shift the digits by one position towards the right hand side, again I'll go with the magic number called as 10, but this time with a result as asterisk. I'll say 32 asterisk 10. Now what is the result? 32 asterisk 10 is 320 plus I'll add the value of r in this case, that is 5. So the result is 325. So I got 32 from this place, multiplied it by 10 and 5 was the result of r in that particular case. Let's check whether the same expression will work for the previous case also. I'll take 3 on the lower side, multiplied by 10. So 3 multiplied by 10 is 30 plus the value of r is 2. Yes, I got the result as 32. Similarly, let's try the same case in the first expression. So 0 asterisk 10, that is 0, plus the value of r, that is 3. So I'll get the value of 3 in this case. So it means that I can use this expression and construct the value of rev as it keeps on growing. Now let's try and summarize this into some variables. I've written this expression with the numbers. Let's summarize this. Now 3, 2, 5, they are nothing but the values of r. So I can write this as r plus, number is constant over here, 10, asterisk. Now 0, 3, 32, they flow from what? They flow from a variable called as rev. So I'll say rev. Where the result gets accumulated, the result again goes to rev. So it means that I can use a logical expression as rev equal to rev asterisk 10 plus r, so that I can store the reverse of the number. So here, when the digits are extracted, and just add up one more expression, that your rev value is equals to rev asterisk 10 plus r in this case. The value of r gets added with this expression called as rev asterisk 10, and the result is stored back to rev in this case. So rev equals to rev asterisk 10, and I can say reverse of the number is percentage d comma rev. So when you run this code, you will be able to get the reverse of any number which is inputted, where the memory variables will go with this particular logic. So the expression has been constructed not directly but on observation. 3 to 5 correspond to r, 10 is constant, 0, 3, 32, they come from rev, and the results they go back to rev, hence it is rev equal to rev asterisk 10. Suppose if this expression would have been written with s, in that case I'll say s equal to 0, and here rev would have been replaced by s. So I'll say s equals to s asterisk 10 plus r. So, and then I would have displayed the value of s over here. So do remember that the reverse of the number is supposed to be constructed, not just displayed. There is one more logic. You can just print the value of r over here. If you print the value of r, first time it prints 3, next to that it will print 2, next to that it will print 5. But when I say 3 to 5, the numbers which are there on the screen, you might get an illusion that it is reverse. But it is not actually reverse. 3 numbers have been printed one after another so compactly that when I look at the number, I'll get an illusion that it is the reverse of the number. But exactly it is not the reverse, it is just the individual digits which have been displayed. So make sure that you construct the reverse, not just place these individual digits, right? So remember that you are supposed to construct the number so that it can be operated further for some operations. Thank you.